Okay, so what now? We have learned a lot about blockchains, and maybe you're no expert yet, but you're still a little confused about all these terms: blockchain, smart contracts, EVM, consensus, fork. Okay, shit, what now? How can we use any of this? Well, you might have heard of the term DApp. It stands for Decentralized Application and is the most common way to make use of smart contracts. So, what is a decentralized application? Well, some people call even just one smart contract already a decentralized application. Technically, that's all one needs to run applications on Ethereum. There are millions of smart contracts running on Ethereum, and for some, the only way to use them is if you're a developer who knows what he's doing. Shit, you might be thinking, I'm a developer, but I don't know what I'm doing. And hey, don't worry, I feel the same way. We all know people need easy ways to use decentralized applications. That's why usually they are built with a nice website to go along with it. So what does the architecture of a typical decentralized application look like? As you can see here, this looks similar to a web application. It's actually the same as a web application, except that it additionally has a connection to the Ethereum network. It has a front end, which might be using React, that a user interacts with from his browser. Often a web application has a backend server, which could, for example, be implemented with Node.js. This is something you could have as well in a decentralized application. Maybe you have really large files or a comment system on your website. Then you may need a backend server even for a decentralized application. Or you create a decentralized casino where your backend server is playing the bank. Then the backend has to communicate with the smart contract itself, which is of course possible. Typically though, the Ethereum blockchain is essentially the new backend, meaning you won't see a centralized server in most decentralized applications. Okay, well, let's talk about this blockchain part here now. So we can develop these smart contracts with the programming language Solidity. We can use a tool like Truffle or Hardhat to compile the Solidity code. And compiling here means taking the Solidity code and converting it into code that is made up of only opcodes for the Ethereum virtual machine. Then this list of opcodes needs to be deployed to the network. And deployed means we take the list of opcodes and store it under a new generated address. So then you have your smart contract running on the blockchain, which brings us to the next part. Here we have a wallet MetaMask. If you've ever used a decentralized application yourself, you probably have used MetaMask. Why is this necessary? Remember, any interaction with a smart contract is a transaction to Ethereum. And any transaction to Ethereum is signed with a user's private key. And how can the website access this private key? It would be a big security issue if users just insert a private key on the website. Please, never share your private key anywhere. That's why we have wallets like MetaMask, which is a browser extension. There are other wallets, MetaMask is just the most popular one. And the website will send requests to MetaMask so that a user can sign the transaction with the private key that is securely stored inside MetaMask. And Web3.js is a library that you can use in the programming language of the browser JavaScript. It allows you to communicate with your deployed smart contracts, usually used in the front end, so within the browser JavaScript code of your website. This will then prompt the user to sign a new transaction with a wallet like MetaMask, but technically you can use this on a backend server as well. But here you will need some kind of private key management because by definition you don't have real people using a wallet like MetaMask. And another popular alternative for Web3.js is Ethers.js, which is doing the same thing. Okay, we have ignored this Infura aspect. What does that mean? Well, think about what communicating with an Ethereum blockchain requires. We have to run a node in the network. Otherwise, we cannot communicate with other nodes. Then we have to verify all new transactions if we are running a node, constantly exchange information with other nodes, and also store the whole blockchain's current state. And of course, we want to have this running 24/7 with no downtime. As you can see, this is no easy task. That's why there are services like Infura to help you out with it. It's also what MetaMask actually uses by default under the hood.